Okay, for geometry today, we're doing lesson 2.4, which is deductive reasoning. So we talked about inductive reasoning last week, and this week is, today is deductive reasoning. Okay, so to get us started, deductive reasoning, okay, uses established general principles to reach a specific conclusion that must be true. All right, so then we have this nice little diagram of logic. Okay, what logic is. Last week we looked at specific instances or examples, and we talked about counterexamples even. But we looked at examples and we used inductive reasoning to come up with a conclusion. Well, that can lead us to forming some general principles in math and any kind of logic at all. Well, once we have those general principles, we can apply those now and have some deductive reasoning. So it's that we're taking those general principles that we've learned and we're doing some deductive reasoning and drawing a conclusion that must be true from those principles. So let's look at example 1. Okay, it says classify each argument as inductive or deductive. All right, so A, all squares are rectangles and all rectangles are polygons. Therefore, all squares are polygons. Okay, so is this inductive? Are we looking at specific instances or examples? Or is it deductive because we're drawing our conclusions from general principles? Hopefully you got that it was deductive. Because we know there are general principles about what a rectangle is, right? It has to have 90-degree angles and 4 sides. Rectangles are polygons, okay? Polygons are any closed shape. Okay, so rectangles are polygons. Therefore, squares are polygons. All right, that's all deductive. Let's look at B. A meteorologist studied weather patterns for the last 10 years. Okay, so he's been doing this for a long time. Based on the trends, he predicts, okay, an average high of 25 degrees Fahrenheit in January. So is our meteorologist looking at specific instances and examples, or is he looking at general principles? Well, if he's studying the weather patterns, right? He's studying weather patterns is kind of a key word. For 10 years, he's just looking at examples or instances. So this one is inductive reasoning. Okay, that one is inductive. You'll notice today is also really, most of your notes are going to be there. It's really word vocabulary heavy today. All right. Very nice. Then let's go on to the 3 types of deductive reasoning. If I can get that all in there. It's a tight fit, but I got it. Okay, so there are 3 types of deductive reasoning. Okay, the first one is called modus ponens, which is the law of detachment. Okay, one thing you need to know is this symbol here means therefore. I will use it a lot in class, but we'll use it a lot, especially in this unit. All right, so in logic, a few things you'll notice. Okay, in logic, there's always 2 premises, so premise 1 and premise 2, and then there's a conclusion. So in all 3 of these, we have premise 1, premise 2, and a conclusion. All right, so that's going to be one thing that you notice as we do this. It's very good to notice. All right, so let's go back to this modus ponens, law of detachment. So premise 1 is saying P such that Q. All right, premise 2 is like P happened. And so the conclusion is therefore Q. I know it doesn't really make a whole lot of sense. We'll apply it. When we apply it, it'll make more sense. All right, modus tollens is based on the contrapositive rule that we also talked about last week. So here, if we have P such that Q, or therefore, pardon me, P therefore Q, and our second premise says not Q, then our conclusion is saying therefore not P. Okay, so if it's not Q, then it can't be P either. Last one is the transitive, the law of syllogism. This one is new because we have an R now. Okay, that's that transitive. So if it says P, therefore Q, and Q, therefore R, the transitive part is that we are subbing those in, right? Well then, right? Therefore P, such that R. Okay, so the Q's match up, and we can say, well, P is the same thing as R then, because it was the same as Q, and Q is the same as R. So we can skip around a little bit and use that. It's going to be very helpful. All right, so it's like the transitive in deductive reasoning is like the transitive property of equality, okay? Because it says if A equals B and B equals C, then A equals C. We're doing the same thing here, okay? It's putting that in there. Okay, another thing, it says in a reasoned argument. Let's look over there. In a reasoned argument, we're going to have the supporting statements are premises. Okay, so those first two statements are called supporting statements or premises. The statement premises support is the conclusion. Okay, if the connection between premises and conclusion is logically correct, then it's a valid argument. We're going to look at some of these today, these valid or invalid arguments, and make those decisions. Okay, but if the connection, they have to be connected. The premise and the conclusion have to be connected. If they're connected correctly, then it's valid. Okay, we're also going to talk about soundness. Arguments are sound when true premises, okay, so when there are true premises and valid reasoning produce a true conclusion. So we have to have true premises and true conclusions to have a sound argument. Okay. Again, it's going to make more sense when we get there and actually do it. So let's flip over and look at example 2. Okay, there it goes. All right, so it says evaluate the soundness. We're going to jump right in. Evaluate the soundness of the following argument. If a man is sinful, then he must die. Okay, that's premise 1. Premise 2, man is sinful. And the last one, therefore, man must die. So let's see. We need to check, according to what we just read, it has to have true premises and it has to be valid. Okay, and it's valid if it's connected. So let's check validity. If a man is sinful, then he must die. Okay, so we're talking about man being sinful and then he must die. So then premise 2 is man is sinful. And then it says, well, man must die. Okay, so that is connected, right? It's valid. So let's see, we're going to say it's valid because premises and conclusion connected correctly. Also, can you figure out which of the types of deductive reasoning this is? Is it modus ponens? Okay, which is the if P then Q, and then it says P therefore Q. Is it if P then Q, and then we say not Q, therefore not P? Or is it if P then Q, if Q then R, therefore if P then R? Which one of those is it? Hopefully that gave you plenty of time to figure it out. That it is the first one. Okay? It is that law of detachment or modus ponens, because this would be our P. If man is sinful, then he must die. There's our Q statement. Then we're saying man is sinful. There's our P statement. Therefore, Q, man must die. So this is the law of detachment or modus ponens. Let's just go with law of detachment here. Okay, so we're still not determined if it's sound or not because there were two parts. So first part, it is valid. Okay, we had to check to see if it was valid first. And then the second part was that we needed to know, are the true premises true? So is premise 1 and premise 2, are those true? Okay, if a man is sinful, then he must die. And they're even backing it up with scripture, Romans 6:23. That's true. Man is sinful. Is that true? Again, backing it up with Romans 3:23. So yes, these are true premises. Okay, they're based on scripture. And so that means, okay, if both of these things are true, then it is a sound logical statement. Okay, some common fallacies. Okay, so some common ways that we have invalid reasoning is we assume the converse. So we say, well, if P then Q is the same thing as if Q then P. But it's not true. We can't assume the converse. The other common fallacy is assuming the inverse. Okay, so the inverse is if we say, well, it's if then, or if P then Q is the same thing as if not P then not Q. Well, it's just also not true. Okay, there are things that can be not P but also be not Q. So here's the deal. Nice little star there. The inverse and the converse are not logically equivalent to the original. Okay, they are not logically equivalent to the original. So let's put this into practice as well. All right, so let's move on down to example 3. It says identify the fallacy in each argument. Okay, so let's look at the first one. Let's break it down. It says all dogs are mammals. Okay, so if this is, let's do D for dogs and M. So we'd have if dogs, then they're mammals, is what it's saying. Okay, Garfield is not a dog. So that's going to be a not dog. And then it says Garfield is not a mammal. So now we have not mammal. Okay, which fallacy does this fall into? This is the same as the, well, it was P, if P, then Q. And then it said, well, if it's not P, then it's not Q. So that fallacy was assuming the inverse. Okay, this was called assuming the inverse. Okay, so that's a big one. And you could have labeled those P and Q up there. It was just easier to do like D for dog and M for mammal. All right, let's look at the next one, B. So now we have all dogs are mammals. So now we've got D and M. So if D, then M, all dogs are mammals. Okay. Garfield is a mammal. Okay, well that's an M, so we're going to say, well, there's my statement for that one is M. Therefore, Garfield is a dog. All right, well that's a dog. So now I have therefore dog, which that's not the same fallacy that I have over here. Let me erase this one. Right, these are different fallacies that we have. And so this one is the backwards one. This is assuming the converse. Okay, assuming a converse. Because again, we switched up our order. It was if D, then M. Well, they're stating M and then saying, so this is where the M, if M, then D idea comes in, is what they're saying here. And that's not true. Okay. Whereas here, what they were saying was, if not D, then not M. So that was the assuming the inverse, and this one is assuming the converse. All right, let's look at this star that we have. Because both arguments in example 3 exhibit invalid reasoning, they are unsound, regardless of the truth of the conclusions. Okay, they are unsound regardless of the truth of the conclusions. Perhaps Garfield is a dog, but it could be a fish, and we don't know it. Okay, but if he was a fish, I guess he wouldn't be a mammal. So maybe he's a panda bear. I don't know. It could be that the conclusion is true, but regardless, it's unsound because we have invalid reasoning. Okay, next up, when analyzing arguments, we have to examine the truth of the premises and the validity, okay, of reasoning. Only true premises with valid reasoning are sound. So they have to have true premises and valid reasoning. Okay, so if our premises are true and valid, then our argument is sound. If the premises are true but invalid reasoning, then our argument is unsound. If our premises are false with valid reasoning, it doesn't do any good to have valid reasoning because it's still unsound. And if our premises are false and we have invalid reasoning, then it's definitely unsound. Our arguments are definitely unsound. All right, on to page 3. I understand there's a lot of text in your notes, but a lot of them are the notes, like it's not what you're writing. So hopefully your hand doesn't cramp yet. All right, example 4. Which conclusion can be drawn from the following premises using transitivity? Okay, you may need to flip back and look at transitivity. That was the number 3, the transitive type of deductive reasoning. So that was if P, then Q. Let me write it down here actually where I have a little bit more room. Whoops. Sorry. Got the wrong tool there. All right, so the transitivity is if P, then Q, if Q, then R, and therefore if P, then R is what we're going for. And let me change that color up a little bit. Okay, so let's see, our premise is if a triangle is equilateral, then its angles have equal measure. All right, so let's use E for equilateral and M for this equal measure idea. Okay, so according to premise 1, we have if P, then Q. Okay, P2 says if the angles of a triangle have equal measure. Okay, so now we've got equal measure. Whoops. Let me go back for a minute. All right, let's try that again. We're going to say premise 1 says if E, then M. That's the whole reason we're giving them those names, right? Or those abbreviations. Okay, premise 2. If the angles of a triangle have equal measure. So now we've got if M, then none of the angles are right angles. Okay, so then that's going to be if M, then let's say R. That's right angles. Then none of the angles are right angles. Okay? So which conclusion can we make? According to our guide, we need a therefore, if E, then R statement. Remember, E is the equilateral angle, triangle is equilateral, and the M or the R statement is then none of the angles are right angles. So A says if none of the angles are right angles, that's an R statement. So we already know A is out because we need an E statement first. Okay. B, if a triangle has a right angle, again, we've got this R, but it's not a right angle, but still, that's not what we want. That's a right angle statement. C, if a triangle is equilateral, okay, check, we've got that one down. That's an E statement, like we wanted, right, is equilateral. Then none of its angles are right angles. None of the angles are right angles. That's our R statement right there. So check, we have our if E, then R statement. So our answer here is C. Okay, C is going to be the conclusion we can draw if we're using transitivity to do it. All right, and let's look at example 5. Hopefully we're going slow enough that you're able to focus and you're not having to take too many notes so that you can make it make sense. Oh no! I just realized in my notes I didn't get the answers written down or whited out. So, example 5, evaluate the soundness of the following arguments. Doggone. All right, pigs are dirty. Well, that is a true statement. Cows provide milk. Also a true statement. Therefore, rural areas have low population density. Well, that's a true statement, right? Kirksville has a low population density. All right, but it says evaluate the soundness of the following arguments. Okay, remember, we had to have all true statements. So, all true statements. So check, we've got that. What else did we have to have? Okay, the second part to evaluating soundness, okay, was that the premises and the conclusion had to be connected correctly. So we're going to put connect, or let's do correct connections. So correct connections is our next one. All right, so we're talking about pigs are dirty. Then we talk about cows provide milk. And then we say rural areas have low population density. Do these things have anything to do with each other? Kind of, but they're not actually connected. We're not talking about the same thing and drawing connections. They're all random things. So this does not have correct connections. Therefore, it is not sound. Okay, not sound because no connection. There's no connections between the statements, we could say. But definitely not sound here. All right, let's check out B. All of the animals at the San Diego Zoo are zebras. False. I mean, I haven't been to the San Diego Zoo, but I mean, if it was a zoo, it wouldn't have all zebras, right? That'd be a zebra habitat or something. Okay, premise 2. All zebras eat marshmallows. False. I don't know of any zebras that eat marshmallows. If they do, it's not healthy for them, probably. Therefore, all of the animals at the San Diego Zoo eat marshmallows. Also false. Because, you know, there's other animals at the zoo, but I'm sure they don't all eat marshmallows. Maybe some of them do, but definitely not all. Okay, so let's check these things again. Has to have all true statements. And you're like, duh, Mrs. Talbert. No, it doesn't have that. Okay, which is correct. They're not all true. However, let's also look at the next part, the correct connections. Okay, let's look there. In this case, the connections are actually really solid, okay? Because we're talking about all of the animals at the San Diego Zoo are zebras. So we've got, let's say, A and Z. So we've got if A, then Z. And then it says all zebras eat marshmallows. So then we've got if Z, then M. We're going to put marshmallows for the M. Therefore, all of the animals, A, at the San Diego Zoo, eat marshmallows. So we have a therefore, A let's see, therefore A, what do I have, equals M? Oh, therefore if A, then M. Okay, so this is that transitivity again. It's got great connections. Great connections. So the correct connections are there. It's just that this one is unsound because all the premises are false. Okay? So unsound because premises are false. But I'm going to put a star and say it has great transitivity, though. Because it's, I mean, like, we need to recognize that too. All right, for on your own today, I want you to do page 75, numbers 2, 4, 8, and 12. Okay, it was just too much for me to write out for you guys to write on your paper, so those are your on your own for today, and the sub will have an answer key that you can check as well. All right, have a great day, and I'll see you tomorrow.